outline. First outline is introduction, and next we do related works, and there are gaps and problem statements are there, and objectives are there, and existing models are there, and proposed models are there, and finally the conclusion and reference. First, let's see the introduction. In India, the fake certificates are growing problems, especially in academics and professions and government sectors. Manual verification took time. For example, in India, over 7,000 fake degree certificates were reported in 2020 alone. Traditional certificate storage are centralized, and it make vulnerable and tampering and data loss or unauthorized access. Regulators and institutions face difficulty while verifying authenticity. Manual verification process are insufficient. It took more time compared to online. Uh, let's see about the importance of applications. There are four importance of applications are there. Firstly, the blockchain offers decentralized and immutable ledger, ensuring that when certificate is issued, it can be replaced or forged. Automate trust is done by using smart contract, enabling instant and verification without needing the contract by using institution. Thirdly, storage certificate or metadata on blockchain and IPFS. IPFS is nothing but uh, interplanetary file system that ensures authenticity, transparency, and reducing administrative overhead. And lastly, increasing adoption of blockchains in education HR signal to be shift towards a trustless system. Thank you.
Hello everyone, I'm Shakil Yousuf. I'm going to explain about related works. Um, and it's how different research projects are using in blockchain for educational certificates. And each paper has briefly with a focus on methodology, features, and challenges. And base paper is about working blockchain-based certificates, utilizing blockchain for university certificate verification, and methodologies are university level case study, and using blockchain for using tamper-proof credential, and features are complete to end-to-end process, instrument storage and verification, and we're going to use cryptographic techniques and smart contracts. And challenges are not scalable across multiple universities, and not no revocation features, and lacks performance benchmarking. And second base paper is about a credential verifier blockchain, and using IPFS, and methodologies are designed and prototype an economic credential verification system by using IPFS, and blockchain has of tamper-proof verification. Features are efficient, low-cost verification, and off-chain storage in IPFS, and chain has for integrity, and web interface for certificate search and verifications. And challenges are focused only on Southeast Asia context and large scale deployment and revocation workflows. And third base paper is about blockchain for academic certificates, IEEE International Conference on Advances in Computing, and methodologies are using Ethereum smart contract and stored data in IPFS, and we're going to develop a web-based interface and certificate viewing and validation. Features are reducing manual efforts and time, and publicly verifiable certificates, and product data by using cryptographic hashing. Challenges are complexity and integrating with institutional system, and privacy contracts due to public data access. And fourth base paper is about degree verification system, and using smart contracts and handle including chain revocation to cancel certificates. Features are high privacy and minimal friction, and smart contract based verification. Challenges is about only tested to prototype level, and scalability and real institutional integration are evaluated. Thank you.
First, we're gonna discuss about the topic summary of gap in literature study. First point is lack of real life use. Many systems are tested only in small demo events. They haven't been widely used in real college or university. For this problem, we have a solution that we should conduct program in college and university so that many users will use our platform. Second point is high cost and slow speed. Verifying certificate on public blockchain like Ethereum can be expensive and slow, especially when many users are involved. For this problem, we have a solution that we should use Polygon instead of Ethereum, which can be less expensive and fast as compared to Ethereum. Third point is difficult for non-technical users. Many systems require users to handle crypto wallets or key, which can be confusing. For this problem, we build simple UI using a Streamlit application. Then fourth one is limited privacy control. User often cannot choose which part of the certificate to share. Everything is public, which can expose private data. For this problem, we have a solution that we should create two versions of the certificate. One is full certificate, second is partial certificate. Second, hash and store only the partial data on the blockchain, so that verifier can only access the partial data on the blockchain. Then fifth problem is no easy way to update or revoke a certificate. Once the certificate is issued, it is hard to change or cancel if there is error or if a student withdraws. For this problem, we have a solution that we should create a small table that stores certificate that are no longer invalid, no longer valid. When someone tries to verify a certificate, your app first our app checks that if the certificate ID on the list, or if it is yes, then it is not valid anymore. Then add a corrected certificate. Issue the new certificate with corrected information and store the new certificate and link it to the same student. Then sixth problem is no common standard followed. Different systems work in different ways and don't follow common rules. Employees are universal to verify certificate from other system. For this problem, we have a solution that we should create a common certificate format. Define a We should define a universal template that everyone in our system can follow. Then we have to build the verifier tool that we are using to create a simple tool using Streamlit. Then accept the certificate file and check its the search structure. Then it will be verified. Then we have to share our template to other college so that every college should follow the same process. Next, we're gonna discuss about the problem statement. Today, many certificates are stored in central system or on paper, which can lost, changed, or faked. Verifying them often takes lots of time and must be done manually by connecting the issuing institution. This process is slow, not very secure, and hard to trust. We need a system that can store and verify certificates securely, quickly, and without the risk of tampering or fraud.
Objectives. The first one is build a tamper-proof certificate platform using blockchain. Uh, it creates a secure, trustworthy system where our documents cannot be altered using the blockchain technology. Um, the institution should issue a digital certificate on blockchain. The the institution should create store the signed certificates safely on a public or a private blockchain. Anyone can verify the authenticity of the certificate anytime without needing the contact of the organization. The process of issuing, checking, cancelling the certificates using the smart contracts automated, so that we don't need manual person. It makes the certificates more secure, transparent by storing them in a way that prevents changes, forgery, or accidental loss. And the final one is eliminate eliminate the need of slow and expensive manual checks by using the certificates instantly verifiable on blockchain. Uh, it's like if you're gonna go to the institution and ask about certificates, the process they will be checking our documents manually, and it will be taking a lot of time, and it is like cost effective, and we can look on our documents in our blockchain. Thank you.
Now we are talking about the existing methodology that exists for this project, and this is the outline of centralized system for managing and verifying certificates. So this is how it starts. Like user gets to log in the ID. So the administrative user or institute can log into the system and up to the certificate. And the highlight of the two main actors is that there is a central authority who is responsible for adding certificates to the systems, and institute is the system that can perform other actions. And there's options to add institute whether it is respected to be the authorized user or not. And then the certificate is generated as a hash function, and it is stored in the database, and user get to verify the certificate by uploading the PDFs and certificates, and it can be revoked once it is get to any issues in that. For example, if there is any failure, it can be hacked because it's a central authority, and the generated certificate is prompt to error and attacks. So this can be easily hacked, and there might be so many errors to be caused in this methodology. So we have updated this completely to be in a blockchain based system where users can apply for e-certificates for the universities. And the universities can upload their certificates in the portal where the students can get their own login portal, universities can get their login portal, and the organization who's getting to verify the certificates get their own portal. The certificates are uploaded or downloaded related to the user's demand on a portal. Then the certificate is submitted as a request data which is generated a hash. The hash then function onto the smart contract where it is checked according to the guidelines whether it is authorized and it is prompt to the strict guidelines. If it is okay, then it is updated on a blockchain where it is connected to the peer-to-peer data network. Because this is a decentralized system, it cannot be hacked or edited. Once the certificate is added, even though it contains error, the added certificate cannot be retrieved, so the new item should be uploaded. When the organization gets the certificate, it is uploaded on their portal and that generates a hash. This generated hash checked for the smart contract whether it is verified or not. If it is verified, then it compares with the hash that is already uploaded in the blockchain and validate whether it is a pure certificate or not. Once the validation completes, it checks for the authenticity, and if the certificate is correct and the hash function is matched with the previous data, then it is validated as the output. So here the system is a decentralized and tampering proof, so that this ledger is very useful for the companies to verify the system easily. So it makes the existing methodology to be faster, easier, and faster in the case of accessing the certificates. Now we are looking at the technologies to be used. So we are writing using the smart contract in a Polygon blockchain, which is as previously said, this is less expensive and faster compared to Ethereum. Although the Polygon uses the Ethereum virtual machine, which uses Solidity language to be written. So the smart contract helps to constrain the regulations to be written for verifying the certificates, so that if the certificate goes beyond the regulations, it is rejected. So there is no possible case of being unauthorized certificates. Now we are using IPFS integration. IPFS integration is required to store PDF files. Usually this platform only stores the hash function in detailed blockchain data, but IPFS is used to store the certificate PDFs, so that data problem is reduced. Since this is a decentralized secure file storage, it is not provided in the single area. Then we are using Firebase authentication, which is already pre-written login usage, so we do not need to focus on writing a separate login based thing. So this is easy to develop the blockchain technology in upgraded manner. Then we are using Streamlit app, which is a famous Python language front end model. Can be used to write a helpful and interactive interface for both users, companies, and universities, so that they are ready to use this new technology. And testing and development will be used in truffle test and ganache, where we can test our blockchain methods in local network, so that when we are ready to post in public blockchain, it is error free. And wallet simulation is used to MetaMask wallet, so that here the thing is that everyone cannot access the technology like proper login ID and password. So we are given a public key which is connected to wallet. So connecting the wallet will connect to the technology. So the conclusion is blockchain-based certificate validation ensure it is tamper-proof and decentralized management, and making the verification to be very fast and secure manner. And we are reducing cost by using Polygon methodology. So this is user friendly for all the users, and the user interfaces are demonstrating blockchain potential, so that everyone can be used by this. So thank you.